Hello everyone. Topic for this video lecture is LCM and HCF. First we'll see what is LCM and HCF. Then we'll see some properties. Then we'll do some questions. So let's start. First of all, LCM stands for least common multiple. So what are multiples? Multiples for any given number are all those numbers that the given number can divide completely. Let's say you have 4, so multiples of 4 will be 4, 8, 12, 16, and it goes on. So another property for LCM is LCM for any two or more given number is greater than or equal to the largest of given numbers. Let's say we have two numbers 4 and 16, so the LCM would be greater than or equal to the largest of the given numbers, in this case 16. And let's take another example. uh, the two numbers are 2 and 9, so the LCM for the given two numbers will be 18, which is greater than 9. And LCM for any two consecutive numbers is the product of the given numbers. Let's take two numbers 3 and 4. The LCM for these two numbers will be the product 3 and 4. Product of 3 and 4 is 12. So LCM for 3 and 4 will be 12. Now let's see what is HCF. HCF stands for highest common factors. Factors of any given number is all the numbers that can completely divide the given number. Let's take number 12. So the factors of 12 will be 1, 2, 3, 4, 6 and 12 itself. Another property of HCF is HCF of any two or more given numbers is always less than or equal to the smallest given numbers. Uh, let's take two numbers 4 and 6. The HCF for 4 and 6 will be 2, because 2 divides both 4 and 6, and it is smaller or equal to 4. It is smaller than 4. And HCF for any two consecutive numbers will always be 1. 5 and 6. Let's take 5 and 6. The HCF for 5 and 6 will be 1. Another important property that helps in solving questions is LCM into HCF is equal to first number into second number. This property is valid for any two given numbers. So let's see how to find LCM. Let's take two numbers 3 and 17, or let's say 3 and 15. So first of all we write all the smallest number greater than 1, which can divide 3 and 15. So 1 will divide, 2 cannot divide, 3 can divide both the numbers. We write 3 ones are 3 and 3 fives are 15. While taking out the LCM, now after this step you cannot divide it any further. You don't have any number which divides both the number which is greater than 1. So we move in this format and multiply all the given numbers. So here comes 3 into 1 into 5. LCM for 3 and 15 will be 15. Let's take another example with more numbers, more than two numbers. Let's take 3, 5 and 18 and 25. In case when you have more than two numbers, you have to do the same. Start with the smallest number that can divide at least two of these given numbers. So if we take 2, the only number that 2 can divide here will be 18. If we take 3, the numbers which can be divided are 3 and 18. So beginning with 3, divide this. For the numbers which are not divisible, we write it as it is. So 5 will be written as it is. 18 is divisible by 3. 3 6 is 18. 25 is not divisible by 3, so we write it as it is. After 3, we can no longer divide this with 3 or 2. The only number that can divide more than 2 numbers is 5. We divide the numbers which are divisible and leave the numbers which are not divisible as it is. So 1 will be written as it is. 5 will be written, when divided by 5 we write 1. 6 will be written as it is. And 25 when divided by 5 we get 5. Now we don't have any number greater than 1 which can divide 2 or more than 2 numbers properly, completely. So we move in this L manner and multiply all these numbers. So LCM will be 3 into 5 into 1 into 6 into 5. So it will be 3 6 is 18 and 5 5 is 25. Get 18 5 is 9, 0, carry 9, 18 2 is 36 and 9 45. LCM for 3 5 18 and 25 will be 450. Now for how to find HCF, in order to find HCF for any two given numbers, let's take 16 and 18. We do the same procedure. We start with 2, and the thing with the thing different here with HCF is when you are taking HCF for 2 or more than 2 numbers. Let's take another number as 24. The difference when you are finding HCF is different from LCM is when you are given problem with more than 2 numbers, the number you write here must divide all the numbers, not at least 2. With LCM we took numbers which would divide at least 2 of the given numbers. So starting with 2, 2 8s are 16, 2 9s are 18 and 2 12s are 24. Here 8 and 12 are still divisible by 2, but since we are taking HCF, we need all the numbers to be divisible by a single number. So only one comes here which can divide all these numbers completely. So in HCF, we move only in downward direction, taking product of all the numbers in downward direction. We do not take these numbers which we had previously taken while taking LCM. So HCF for 16, 18 and 24 will be 22. Let's take another example. Just a second, let create a space. CF for 12, 32 and 20. Let's find out HCF for these three numbers. Beginning with 2, 2 6 is 12, 16 for 32 and 10 for 20. 10 are 20. Another number which can still divide all these numbers is still 2. we only increase the value this side only when the numbers are not divisible with the given number. So 2 3 is a 6, 2 8 is a 16, 5 is a 10. Now we have reached a state where these numbers are no longer divisible by any other number. So HCF will be product of all the numbers that we got here moving downwards. So HCF will be 2 into 2, 4. I think we are clear on how to find LCM and HCF. Now let's move to some questions. What is the LCM of 25, 30, 35 and 40? First write all the numbers. Just a second. To find LCM of 25, 30, 35 and 40. Let's start with the smallest number which can divide all these numbers. We take 2 because 2 can divide 30 and 40. We need at least 2 of these numbers that can be divided with the number we write here. So 2 cannot divide 25, so we write it as it is. 30 can be divided, so we write 15. 35 cannot be divided, so it will be written as it is. 40, 220, 2 into 20 we get 40. Now the next number that can divide at least 2 of these given numbers will be 5. 3 can divide 15, but any other than 15 will not be divided by 3 completely. So after 3 we go to 5. And remember guys, all these numbers are prime numbers. So after 2 we will not be using 4 because if it was still divisible we would write 2, not 4. We write prime numbers in this side. So 5 5 is 25, 5 3 is 15, 5 7 is 35 and 5 4 is 20. So as we did earlier, LCM will be product of these number making the L formation. So LCM will be 2, 5, 5, 3, 2, 7, 4. Five, 6, 5 3 is 5 3 is 15 and 7 4 is 28. 28 into 15 into 2 5 is 10, 5 3 is 15, 7 4 is 28. 28 is 140. Carry will be 14. 28 1 is 28 and 14 will be 8 and 14, 42. 42 into 10, 4200. So the answer will be 4200. This is the correct answer. Now we have another question where we have to find the HCF of fractions. So whenever you have to find the LCM or HCF of fractions, you find whatever you are asked for the numerator. So here we are asked to find the HCF. So HCF of numerator upon LCM of denominator. So HCF for HCF of 4 10 and 20 upon LCM of 9, 21 and 63. Since the number are simple, so it is easy to find the HCF. HCF cannot be 4 because 4 cannot divide 10. So less than 4 will be 2. 2 can divide all these numbers. 2 2s are 4, 2 5s are 10 and 2 10s are 20. So HCF for these numbers will be 2 and LCM for these numbers 9, 21 and 63. The largest LCM will be greater than or equal to 63. 9 can divide 63 completely, 21 can divide 63 completely. So LCM for the denominator will be 63. So we have our answer here 2 by 63. Let's take another question. The HCF for two given numbers is 29 and their sum is 174. The possible numbers are, since the HCF is 29, so and let's suppose the numbers are A and B. So A and B are must be divisible by 29. So let's check out all the options. 1 and 174, this will not work because 29 cannot divide 1. 74 and 100, they are also not divisible by 29. Here we have uh, two options, out of which 29 5 is a 145. This is the only possible answer, and their sum is also 174. 29 plus 145, 9 5 14, carry 1, 4 2 6 1 7. So this option satisfies the given condition that both the numbers are divisible by 29, their HCF is 29 and their sum is 174. So the fourth option is correct. Now we take another question. Two numbers are in the ratio 15 and 11. If the HCF of number is 13, find the numbers. So let's say 15. Let's suppose the numbers are A and B. A is 15 into 13x and 11 into 13x. Since we are told that 13 is the highest common factor of A and B, which means x, the value of x will be 1. So A we get 13 5 is 65, carry 6, 13 1 or 19, 195. Option B, 13 13 143. So we have our numbers, A is 195 and B is 143. So the answer we get here is option 4. We have another question here. Three bells toll at interval 36, 40 and 48 seconds respectively. They start singing together at a particular time. When will they toll next together? So we have three bells. Uh, so bell A, let's name them bell A, bell B and bell C. They ring at 36, 40 and 48. They each ring at a different time, at a different interval, but they start at the same time, so we have to find at what time they will ring together, which means we have to find the LCM at that time they will all ring together. So LCM for 36, 40 and 48. Smallest number which can divide them will be 2. 2 into 18, 36, 20, 48 we have 24. Just dividing all of these numbers by 2. We can still divide them by 2. 2 9s are 18, 2 10s are 20 and 2 12s are 24. Two numbers are still divisible by 2. So we'll write 2. 9 is not divisible, so it will be written as it is. 2 5s are 10 and 2 6 are 12. Now 9 and 6 are divisible by 3. 3 3s are 9. 5 is not divisible, write it as it is. 6 is divisible by 3. 3 2s are 6. Now these number will further not be divisible by any other number except 1. So taking LCM going in L fashion, LCM is equal to 2 into 3 into 3 to 5 into 2. So we have 4 2's. 2 to the power 4 will have 16. But if we leave out 1, we can have this as 10. So 2 to the 4 to the 8, we write it as 8 into 3 3s are 9 into 10. 8 9s are 72 to 10 720 seconds. Now we have 720 seconds. To convert this into minutes, we simply divide 720 by 12. 12 6 are 0 0. Sorry. We have to divide it by 60. Let me move this. In order to convert seconds into minutes, we divide the seconds by 60. So we have here 720 seconds divided by 60. We get 12. So the answer for this question is option 2, 12 minutes. We have another question here. Find the side of the largest square slab which can be paved on the floor of a room 5 meters and 44 centimeter long and 3 meters 74 centimeter broad. So let's write the length and breadth in centimeter. Length is 544 centimeter. Breadth is 374 centimeter. So we have a rectangular path with side 544 centimeter and 374 centimeter. We have to choose the uh, size of a square slab which is a multiple of both, which is a factor of both 544 and 374, so that these square plates will have an integer number on the length side and on the breadth side. And since we are asked with the larger size of the square, so we have to find the HCF of 544 and 374. The HCF will divide 544 in a complete manner and also 374 in complete manner. That is why we are finding HCF. So 374 and 544. First it is divisible by 18 will be 36. With 6 1 will be left. 14 7 27. This is further not divisible by 8, 7, 15, 1, 16. It is not divisible by 3, not divisible by 4, not divisible by 5. Since it is not divisible by 2, so it will not be divisible by 6. Let's check for 7. 7 2 is 14, 37, so not 7. Next prime is 11. Uh, 11 will divide 187 but not 272. 11 2 is 22. We have 52 not divisible by 11. Next prime is 13. 13 will not divide any of them. After this the prime is 17. 17 plus 76 or 102. So next number will be 17. 17 into 11, 187. 17 1 is 17. 102, 17 6 is 102. So finding HCF, we go in the downward manner. We have HCF 2 into 17. So the largest square slab will have the length of 2 into 17 centimeter, which is 34 centimeter. Option 3. Let's take another question. The LCM of two number is 7700 and the HCF is 11. One of these numbers is 275. What is the other number? So we had read this property that LCM of first number into second number is equal to first number into second number. We have LCM and HCF. LCM into HCF is equal to first number into second number. We are given LCM is 7700 and HCF is 11. We are given one of the numbers 275. Let's say the other number is X. So X will be 7700 into 11 divided by 275. So dividing this, we can divide this with 25 because 700 will be divisible by 25 as 700 is divisible by 100, which is divisible by 25. So we write 25 in the 25. Here comes 11. This will be 25 3s are 75. 2 will be remainder. That's 20. So 308. 11 will cancel out 11. So the value of X comes out 308. So the answer to this question is option A, 308. Let's take the last question for this lecture. There are three different containers: 496 liter, 403 liter, and 713 liters of water, respectively. What is the capacity of the biggest container that can measure three different quantities evenly? So we are given here. It's we are given three containers: 496, 403, capacity of 403 liters, 96 liter, and 713 liters. Now we have to select the size of a container which we can evenly fill. Using this container we can evenly fill all these containers. So what we are trying to do here is trying to find such a size which will divide 496, 403, and 713 completely. So basically we are looking for the HCF, since the question has asked the biggest container, the capacity of the biggest container. So we are finding HCF of 496, 403, and 713. For such questions, if you look, 496 and 413 will not be easy to find out which numbers will be able to completely divide them. And since we can see in the options, all of these numbers are prime numbers. So starting with the option 1, let's see if 17 can divide all these numbers. 17, 44, 44, 6. 17 can divide 496. Let's see if 17 can divide 403. 17 to the 416, 163 is 17 can divide 403 as well. Can 17 divide 713? 17 5 is 17 4 is 68, 68 33. So 17 will not divide 713. Let's move to option 2, 31 liters. 496 divided by dividing 496 by 31. 13 1 ja 6. 31 into 6. 6 1 ja 6 and 6 3 is 18. So 31 will divide 496. Prime 403 with 31. 31 1 ja 9 3 31 into 3. 30. So 31 also divides 403. Let's try 713 with 31. 62 93. So we can see 31 is the biggest number among the options, and 31 is also completely dividing all the given numbers. So answer will be 31. Answer is 31 liter. The capacity of the biggest container that can measure three different quantities evenly will be 31 liter. So that's it for this lecture. We'll see again in the next lecture. Thank you guys.